Chapter 1 gives us an overview of the systems development process. You probably haven't thought much about how systems or software applications are put together or developed. You're probably aware that there's some coding involved, as well as some internal or alpha testing, and there may be some beta testing as well. But that's just part of the whole picture behind systems development. There is a lot of planning involved before any code is written or any networking equipment is purchased. When we talk about methodologies, we're talking about ways that an organization goes through this process of analyzing, designing, implementing, and maintaining a system. There are several methodologies out there today, and each one has its usefulness depending on the situation. The oldest model is the Systems Development Lifecycle, or SDLC. This is distinguished by its distinct and discrete phases consisting of planning, analysis, design, implementation, and maintenance phases. It's cyclical in nature in that the end of the useful life of one system leads to the start of the next. If we were to look at Windows, for example, we can see how this works out. Windows 8 went through a process like this as it was being prepared for the public, and once it hit the shelves, the development team fixed bugs and released service packs, and eventually Windows 8.1, which is all part of the maintenance phase. At some point, a decision was made to come up with something completely new, because there were too many bugs to fix, or because there were new technological developments, or whatever the reason may be, moving us from the maintenance phase back to the planning phase to start a new product, which eventually became Windows 10. The SDLC isn't always a 5-phase process. Some organizations might combine phases, and others might add 1 or 2, depending on their needs. The names of the phases might not even be the same from organization to organization, but the ideas behind them are the same. If you understand the general flow behind projects that follow the SDLC, you'll be fine. In some places, you might find the SDLC referred to as the Waterfall model. Some organizations think of the process in a linear fashion rather than a circular one. The concepts behind the different phases are the same in either case. The planning phase involves figuring out what projects are important to an organization, discussing the problems to be solved, and developing a rough idea of what the end result will be able to do. The analysis phase dives deeper into the problem and starts to detail what the requirements will be. The design phase lays out what will be needed to make this happen in terms of the specifications of the hardware and software and where everything can be procured. The implementation phase is where all the work gets done, and the maintenance phase is where any problems or bugs are fixed. We'll get more specific with what each phase does in future chapters, but for now, get a grasp on the general ideas behind each of the phases. The methodology can get problematic if you follow it the way it was designed. This model was developed back in the early 1960s as a means of controlling government projects, and the intention was to make sure that at each phase there were clear objectives or milestones to meet and a way to get out of the project if things weren't going as planned. This rigidity can lead to issues. For example, if you're on the design phase, you should already know what the design requirements are so that you can start coming up with a plan to meet those requirements. You should know that your system will need to be accessible on mobile devices and take both biometric authentication as well as your typical username and password combinations. These requirements originate in the planning phase but are typically fleshed out in the analysis phase. If someone wanted to make changes to those requirements, that could possibly have a huge impact on the design aspects, so generally speaking, changes need to go through a vetting process before they're accepted as part of the requirements. There's also a heavy emphasis on meeting deadlines. We'll see in future chapters that changes to the timeline also may affect the budget and the scope of the project, which in turn could affect the overall quality of the project. All this doesn't make the SDLC obsolete. This methodology can be useful if you have large projects with many different sub-development efforts, or it can be useful if you have a specific idea of what the end result is supposed to do or look like. For smaller projects, there are other options. Evolutionary models are sometimes known as spiral models because of the constant iteration involved. Evolutionary models sometimes use the same phases in the SDLC, but the key difference is that there isn't really a specific end goal to meet by the time you get to the maintenance phase. At that point, you can decide to add or remove features based on user feedback. Many games are developed using this concept. A company may put out a beta version, get feedback, re-release, get more feedback, and then go wide release. This model gives the team a lot of flexibility in terms of getting just the right features in place while creating different prototypes to analyze their work. But the more cycles you have, the longer a project goes and the more you spend on that project. Agile methodologies also follow iterative methodologies, and these models aim to have a project completed as quickly as possible. Like the spiral model, Agile methodologies can be used for projects where requirements are unpredictable, and you need to have heavy involvement from your development team, as well as the end users or customers. Agile methods are more for software development versus systems development, which may include new hardware infrastructure in addition to software applications. Two of the more popular Agile methodologies are extreme programming and Scrum. Two other methodologies are object-oriented analysis and design and relational unified process. Both share commonalities with object-oriented programming, where you deal with objects, methods, and inheritance. RUP follows a four-phase model: inception, elaboration, construction, and transition, which, when you break down what happens in each phase, has a lot of the same characteristics as the SDLC. In summary, be familiar with what a development methodology is and the general steps that the SDLC follows. Also know that there are different models that organizations use, including Spiral, XP, Scrum, OOAD, and RUP. You don't need to know all the details behind the different phases and the teams involved, but you should know some general characteristics such as their use in large or small projects or their iterative natures. This course will focus on the Waterfall methodology for the most part, but the concepts should translate into the other models should you encounter those in the future.